Okay, had a little screw up on the previous video, so this is take 2. So we are proving a quadrilateral is a rhombus. And so what makes a rhombus is the fact that all 4 sides are congruent. So in order to prove that all 4 sides are congruent, you'd have to use the distance formula 4 times. Or we could prove that diagonals are perpendicular to each other. So with that, we'd have to use the slope formula twice. I don't know about you, but I'm kind of lazy, and I would prefer to do 2 formulas instead of 4 formulas. So we are going to be dealing with the diagonals. So I already have my quadrilateral here. I'm trying to prove that quadrilateral ABCD is a rhombus. So remember, we are going in a consecutive order. There's my order of pairs. So if you need to pause the video to copy those down, please do that. So we are looking for, are my diagonals perpendicular to each other? So in order to use perpendicular, we're going to use the slope formula. So I'm looking for the slope of line for segment AC. So slope, we're using the change in y. So 3 minus 6 over negative 2 minus 7 gives me a negative 3 over a negative 9. Gives me a positive 1/3. Now let's kind of think about that for a minute. What would make it perpendicular? And that would be if the slopes are opposite reciprocals. So I have then BD. So I'm using find the slope of BD, so 3 minus 6. I don't know why I put a parenthesis there. 3 minus 6 over 3 minus 2 gives me a negative 3 over 1. So the slope of AC is 1/3. The slope of BD is negative 3 over 1. These are opposite reciprocals. Therefore, the diagonals are perpendicular. Therefore, it's a rhombus. Okay, if we use the distance formula, we would find that all 4 of these segments would in fact be congruent, which again is just another way of making it a rhombus.